Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today is going to be basically on presentation, and the students have actually prepared work especially on the elements of weather, mainly to look at the different instruments that are used, and the students are going to explain how those different instruments can be read or how they are used. To recap on what we have covered so far already, we've looked at the definition between weather and climate. We have not started on the subtopic on climate as yet. We are still looking at the subtopic on weather. We looked at the different elements of weather, a description to each one of those. The elements of weather again are temperature, rainfall, cloud cover, cloud type, wind speed, wind direction, humidity, pressure, and sunshine. We also looked at the instruments that are used for recording and measurement of those different elements. And as well as that, we have also looked at the different unit of measurement for those different elements of weather. You were given a task, and the task or the activity you were supposed to have completed was, in your groups, you were supposed to explain the different parts of the instrument that are used for measuring the different elements of weather. We had 9 groups, and the 9 groups covered each of those different elements. Also, your groups, or in your groups, you were supposed to explain how we can actually read information correctly from that particular instrument you were allocated to work on. So I am now going to hand over to the different groups for your presentation, and your presentation should at least explain the uses of those different instruments used for recording and measuring the elements of weather. We'll start off now with our first group, and our first group will tell us what element they have been assigned to work on, and also explain to us the different instrument and how to read information from that particular instrument. Okay, first group. Sorry, before our presenter also does the presentation, remember, you are expected to do your note-taking, because whatever the person presents here, it might be useful when it comes to our testing or when it comes to the test. So your note-taking is also important.
Our group, we're going to present to you the thermometer. A thermometer is an instrument for measuring temperature, how hot or cold an area or place is. Although thermometers come in different shapes and forms, the liquid, usually mercury, is held in the bulb. As the temperature rises, the liquid expands, moving up the bulb. The bulb is measured at different intervals to give the room temperature. This can be read off in degrees Celsius.
Any questions for that particular group? Yes, there's a question out there.
When you say the mercury expands, it expands because it's getting colder or hotter, the temperature?
As the temperature rises, it expands, meaning it's hotter, so the mercury moves further up. You have mercury in there because it does not evaporate like water.
Any other questions? No other questions? Okay, we put our hand together. Thank you to that group for the presentation on the first instrument. The next group, group 2.
Our group is our presentation is on the rain gauge. A rain gauge is an instrument used to measure rainfall, and it consists of a funnel, and a measuring cylinder in a container, plastic container.
Hold the funnel for the camera and the measuring cylinder so that they can also see properly when you are presenting.
All weather stations have a rain gauge. As rain falls, it trickles into the funnel and then into the jar. At the end of a 24-hour period, this is poured into a graduated measuring cylinder. The rainfall is measured in millimeters.
When you go up, I think you have to show those instruments. I can tell them, okay?
The position of the rain gauge.
Hold on.
It must be placed in an open space so that no runoff from buildings or trees, etc., enters the funnel. It must also be sunk into the ground so that about 30 centimeters of it sticks up above ground level. This prevents rain from splashing into it from the ground and also prevent the sun's rays from causing excessive evaporation of the water already collected in the jar.
When you want to measure the amount of rainfall that is fallen, you take the reading from here, from this measuring cylinder. It's measured in millimeters.
Just to summarize again, a rain gauge consists of a funnel, a measuring cylinder, and a plastic container which the measuring cylinder sits in.
Thank you. Okay, thank you to that group. Maybe there might be some questions with regards to that instrument on the cylinder, measuring cylinder or the rain gauge. Any questions from the class for that group? No questions? Okay, good. We'll move on to group number 3. I wanted wanted you to summarize simply because some people don't know that this is a funnel. Some students from the other schools may not know that this is what is inside the container. So you have to stress to them. They think that you just put this one out and it collects the rain, but it doesn't. Exactly. That's why I wanted you to stress. We are fortunate to have this. For them, they do not have, so it's better to always show it to them. I'll leave it here.
Good afternoon, class. Shelly and I, what, will be explaining on the cloud cover and how it is measured. Cloud cover is measured in octaves. As you can see, cloud cover is measured in fractions of 8, and each fraction has an octaves unit, as you can see.
This symbol here represents a clear sky. That's 0/8. And as you make your way down, this proportion here comes after 5/8, and that's like nearly like like a full cloud, like very dull sky. And this here, that's like complete cloud cover. Yeah, and that's about it.
Any questions for that group? Okay, there's a question up front. Yes, Val?
How can you tell if it's 3/4 or full cloud cover? Totally. The cloud cover of the sky, 7/8 and 8/8. How can you tell that there's still some gaps left so you say it's full cover?
The instrument used for measuring cloud cover is simply observation. So as you observe, like you can tell whether it's covered or not.
So, your question, Val? Sort of. Okay. Use your eyes. That's what Salasi said. Okay, if it's like really dark, that's 8/8. That's full, completely covered. Does that satisfy you, or? If there's little sunshine, well, that's definitely 7/8. And
There's a question here. Can we pass the mic from the back to the front, please? Okay, one more question on cloud cover.
Would you consider stuff like mist and fog as cloud cover?
Yes, we can. Shit, we didn't draw the last.
you said if fog and mist is included in. Okay, definitely yes, because it's like, covering like the sky. So yes.
There's one more. Last question.
Do the weather stations use satellite pictures also to tell about the amount of sky which is covered by clouds? Do the weather stations also use satellite pictures to tell if the sky is three-quarters or covered by clouds?
It's just mainly observation from your eyes. So I reckon no, you don't use. Well, from my knowledge, yeah. Going back to Mason's question, what does it? You said mist and fog.
Going back to Mason's question, you were wondering if fog can be considered as cloud cover as well. Well, according to the weather, the book, sorry, according to the book, yes, it is considered as cloud cover. And as you can see, these are two diagrams which describe them. This here, with the X in the middle, describes sky obscured or fog, and the ones with the line going outside of the circle describes the missing or doubtful data, in which they have dealt with the data. Does that answer your question?
Okay, I think I said the last question also from the class, so we'll put our hand together for this, the two students. Okay, good. We'll have the next group to do their presentation. But before the next group does come up to do their presentation, be also mindful that if you send Celesi and Shelley out to give information on cloud cover, and if we want to have first-hand information, they will have to be specialists. That means they must study to become meteorologists so that they are able to give you the correct information. We are looking at the information from what we can observe without maybe so much knowledge in terms of meteorology. And we can give them credit for what they have mentioned in terms of cloud cover. We divide the sky into eighths, and then from there we can work out what proportion out of the eighths is actually covered by clouds to be able to say 1/8, 2/8, and etc. Okay, thank you. The next group then for your presentation. Sabit. Pointer.
Good morning, class.
Good afternoon.
My group is going to be talking about cloud types. Clouds can be classified according. Sorry about that. Clouds can be classified according to their appearance, form, and height, and there are four basic groups which clouds can be classified: high clouds, medium clouds, and low clouds. Okay, firstly, I'll be talking about the low clouds. Yeah, I'll be talking about the low clouds. The first one is we have is a cloud called stratocumulus. It's a low, rolling, bumpy-looking cloud, and which pronounced kind of a wavy form, and it's usually accompanied by light rain. The second cloud is nimbostratus. Nimbostratus is a dark gray layered cloud which looks rainy and which often brings rain, steady rain. And the last one is stratus. It's a fog-like a low cloud near to the ground level, which brings dull weather, which is usually accompanied by light rain drizzle. And you can see that the clouds which are usually lower to the surface, which are low clouds, they usually bring rain or some sort of precipitation. See?
I will talk about the medium clouds, which form between the altitudes of 2,100 and 6,000 meters above sea level. The cloud in this picture is white, and it's the altocumulus. Its characteristics are globular, bumpy-looking cloud, which has a flattened base and indicates fine weather. The second one down here is the altostratus cloud, which is grayish and watery looking and is usually accompanied by rain.
I'll be talking about the high clouds. These are usually clouds at an altitude of about 6,000 to 12,000 meters. The first one is Cirrus. This is the cloud, as you can see. It's a wispy, fibrous looking cloud, which often indicates fair weather, sort of, yeah. The third one, which is the cirrocumulus cloud. This is a thin cloud, often globular and ribbed. It's often accompanied by possible thunderstorms. And the last one, which is the cirrostratus, this one, it looks like a thin white sheet which causes the sun and moon to have halos, and it's usually accompanied by likely rain after 24 hours. So.
So I made a mistake earlier on. I forgot to mention about the clouds of great vertical extent. These clouds are usually much larger than the other clouds, but which extend to great heights. For example, the cumulus cloud. Cumulus cloud a round top type of a cloud, which is formed white with a black globular masses, whose rounded tops spread out to form a cauliflower shape, or thunderclouds indicating convectional rain, lightning, and thunder. And the second one, which is the cumulonimbus clouds, this special type of cloud which forms white cloud that indicate rain as shown on maps and special stuff like that.
Questions from the class for that group? There's a question up front here. Okay, Gideon, Pastor. Francis, pass the mic up to Gideon.
Where do the evaporated water get to settle? And which layer of the clouds?
You repeat the question again.
The evaporated water from the Earth's surface, where do they get to settle? I mean, which layer of the clouds do they get to settle?
They can get to settle in any of the layers of the cloud. Because when the water settles, it condenses and it forms cloud, as we know.
Any other questions? Val?
Can you look, if you look into the sky, can there be a point of time where there's more than 2 different types of clouds?
It's a possibility that they might have it, but as far as like the books tell us, we're not actually experts upon that, so we wouldn't know.
One more question.
Are there any forces which hold the clouds in their positions, resulting in them being classified as low clouds, medium clouds, high clouds, and clouds of great vertical extent?
Sorry, can you repeat your question?
Are there any forces which hold the clouds in their positions, resulting in them being classified as low clouds, medium clouds, high clouds, and clouds of great vertical extent?
Really, there isn't any force. It's just that they form at that height in the atmosphere. So they're classified as low clouds, medium, and high and vertical. And also their shape.
Last question. Susan.
How often can you check the clouds?
Anytime.
I think I also said that was the last question. Okay, we'll put our hand together for this group. Your note taking on so far the presentations, I hope, is actually taking place. Some of those information are actually important. We have 5 more minutes, and I think in that 5 minutes we might have one more group to do their presentation. Maybe to highlight on some of the points again in terms of clouds. The base of the cloud, that means where the cloud starts, or the bottom part of the cloud, shows us the level of condensation. That is where condensation takes place and the development of clouds begin. Usually the base or the bottom of the cloud. Clouds are actually classified according to where in terms of altitude they are formed. So there is actually no one force that's holding them up there. But where they are formed, whether they are the low clouds, the medium clouds, or the high clouds, depends on altitude. So you can look at the height above the surface, and then you can classify those clouds according to whether they are considered low clouds, high clouds, or medium clouds. We'll have one more presentation, and then the other presentations we'll have for our next lesson. So the last group then to do their presentation today.
Good morning, class. We'll be presenting how to read the wind speed. Firstly, wind speed is measured by an instrument called anemometer. The instrument has three or four arms. It's this one. Pivoted on a vertical shaft. This is the vertical shaft here. Metal caps are fixed to ends of the arms so that when there is a wind, the arms rotate. These are the metal caps. This movement operates a meter which records the speed of the wind in kilometers per hour.
The wind speed can be obtained through approximately by observing the objects moved by the wind. It can be referred to the wind scale.
I'll just summarize what the two boys have said. Wind speed it can be wind speed. How to read the wind speed by using an anemometer. As the wind blows, the metal caps turn, and inside the vertical shaft there's this meter which takes the reading, and you can just read from there in kilometers per hour. Or it can be also through observing the way some objects are moved by the wind. And then by referring to the Bedford wind scale, you can just tell the speed in kilometers per hour. Thank you.
Okay, we are not going to actually ask this group any questions simply because we've run out of time. Any questions that we have for wind speed, we'll leave it for our next lesson. Okay, today so far what we have covered, we have looked at temperature, the use of a thermometer and how to read from a thermometer. We have looked at measuring cylinder and a rain gauge, how to actually read information from a rain gauge. We have looked at the how to measure cloud cover in octaves, and we have also looked at wind speed. Cloud types was also explained to us today, so we were able to look at the 6 different elements of weather in our lesson today. We'll look at the rest of those instruments and the elements of weather in our next lesson. Okay, class, that will also bring us to the end of our lesson today. If you can stand up now. To the pilot teachers, our keyword for lesson 98 is wind. Good afternoon and thank you, students.